thought I would share this. I have 3D printed a representation of the Atlas horizontal milling machine spindle head. And in order to illustrate and check a few things for myself on how it works, a couple issues that I noticed and trying to figure out what's going on with this particular machine. So I thought I would share it. There's been a few videos that I've seen and trying to show assembly and how this goes back together inside of the spindle, and you can't, you have to have 1.5 hands in there plus trying to get light in there. It's extremely difficult to see what is actually going on in there. So for those of you that have followed along for a while, you know that I'm also like 3D printing, and I thought what an opportunity to use 3D printing and show what's going on in here. So just a couple of issues with this particular machine. This is the back gear eccentric, and this is the front, which is an M1 251, and a lot of these are broken. I'm guessing because of folks maybe not understanding how to mesh gears, but you'll see a lot of machines with this particular piece remanufactured. I did get a donor from a friend of mine. Thank you, Richard. This one here, I've been modeling it, 3D modeling it, trying to understand whether it could be a printed part, cast. We'll see what we can do with that. The second issue that I wanted to show was this gear here. And this is the back gear. And not sure how well it's showing up on camera, but there's damage on the tops of this gear here, and I was trying to figure out, when I had pulled it apart, I was trying to figure out where that was coming from, and what I found, this plunger. This plunger is what connects this back gear to the spindle pulley. So when this plunger is out, and remember, you got to do all this. You got to do all this through a little hole in the casting. When that plunger is out, the spindle pulley runs free of this back gear. And what that does is that creates your back gear where you're running this pulley to this small back gear on the spindle, which translates up to the back gear here, over to here, back to this front gear. And this front back gear on the spindle is keyed, so you transfer your power through to here and you get your back gear. Now, inside of here is supposed to be a 1/8 ball with a spring and a set screw to hold it. And so as you put this in and out of the pulley, the ball plunger goes down into the groove on this. On this particular machine, there was no spring, there's no ball, and somebody had a set screw, which was rather long. And what I've noticed is, let me put it in back gear here. I'm not sure if you can see that, but that set screw is lining up directly with the damage on this back gear here. So what happened was this thing ran around with this out and because of the gear ratio, it's not mesh, but anyway, because of the gear ratio, this thing came around and hit, you know, hit every fourth or fifth tooth, whatever it is. I don't know what the gear ratio is, but that's where all this damage came from. So this plunger should have a ball detent with a spring and a set screw that should be locked in, not sticking out like that. Next thing I wanted to point out, I was really confused at what was going on here when I was taking this apart. This was a set screw that was in this pulley, and I couldn't figure out what was happening there, because I knew that this plunger linked the pulley to the back gear on the front. I had seen that in other videos, and I'll show that later, but I wasn't sure what the set screw was for. And then you can see another one here on the back gear set. Same thing. It's this gear is meant to rotate freely here, so why do we have a set screw? Well, I've since found out these are for oiling the bushings that are in here. There's a bushing, 2 bushings in this, 2 bushings in the pulley, and or 1 bushing in this pulley, and then 1 bushing up here in this gear, which is a standard Atlas system where they lock that gear to that pulley with some tangs on it. So that's what those 2 set screws are for. Again, this set screw is for the plunger and ball detent, and then there's a set screw here which is 90 degrees out from the keyway on this gear. So one thing that is extremely important, so when you take this apart, and you got to imagine we've got a casting around here, but the eccentric for this back gear, and you can see how that's linked now, and if you watch the rotation here and the rotation on that pulley, like I say, I don't know what the ratio is, but it's at least 3 to 1. So in the casting, there's an attached, you can see the eccentric. There's a pin that goes through for the shaft. So this eccentric and the one on the back side have to be in time. And when you put it together, the pin has to go through the shaft, so that as you turn this selector handle, the axis of this back gear rolls in and rolls out of engagement. And you can see how that works. And again, you got to be careful. You got to make sure it lines up. That's a no-no. That's exactly what was happening. Actually, it looks like it's 2 to 1. So this is top. Or no, it's not 2 to 1. This is top. This is top. Once. 2 and a bit. Anyway, and then the only other thing going on with this back gear, these 2 collars. These 2 collars are just set screws. And what those are for, that's to put this gear, to put the entire assembly in the right place to get alignment. And then I've printed this so that comes out. So you can see there's just a collar to hold that position there. That's the eccentric. Collar to hold this position. And then I've got this pinned. So you would have to take this pin out on the machine prior to getting this apart, because you have to pull this shaft out the back. So now with the back gear out of the way, one other thing I want to note is, I think you can see it here, there's four dust covers. Two large, one on the front, one on the back. This is the back over here. And two small dust covers. Now I did not account for that diameter in this housing, so it's just sitting there loose, but normally this dust cover would be pressed into the inside of the casting. And I'll go through assembly, what I believe would be a good assembly process, but these would be in place first. The key with these outer dust covers is this notch right here. This notch lines up with the hole. There's a hole in the casting right at the edge of the race that comes out the top to a Gitz oiler. So if you don't have this lined up, you won't get any oil to your bearings. And there's one on the front and one on the back. Same thing, the alignment has to be there. This is your cutout to get oil to your bearing. So disassembly. This thing here, this is called a spindle adjusting collar, and that's an M132. That's got to come off. It's got a little... not sure whether it would be a set screw. This has got a slotted head in it. Maybe somebody's made one of these up after. So you've got that comes off. You've got the spindle gear, which is... that's the M1 100-32. And I believe the 32 is the designation for the number of teeth. There's a key. So again, this is all being done right now from the outside of the machine, so you got no problems there. This is the spindle bearing spacer. This is an M178. So that would come off. And so at this point, the dust cover is going to be inside the casting, and you're now going to have to start moving the spindle. So the thing that holds the pulley in place, this pulley, when disengaged from this back gear through that plunger, is allowed to spin. So it's not, and remember, this is just for oiling. So it's not attached to the spindle in any way other than through the bushings, right? So this should rotate freely on the spindle. And then, so in order to start moving the spindle, you've got to disengage this back gear and this collar from the spindle. So this collar here is just a set screw. So now it's loose, and then this back gear, there's a set screw down inside of here, which is 90 degrees to where the keyway is. So now this one here, that set screw's backed out, that collar's backed out. So now this whole assembly, which is a back gear, the pulley, and a back gear, is loose. Now, keep in mind, I have had all these parts apart, and I've, stoned and polished and made sure I have everything ready for a smooth reassembly, because you don't want to be fighting anything when you're inside of this casting, because you can barely get it together. So, so now with all of that loose, the spindle can now move through this bearing, and this assembly stays stationary as the spindle goes out. So now the goal is to move the spindle through all of this stuff and out. And what's going to happen is we're going to push, and I believe I'm actually going to look at how to use this thread, the casting itself, to create a puller and pull this spindle, because that's what you want to do. You want to have all of this stuff loose in here. And the only other thing right now, so the set screw's loose for this, the set screw's loose for the collar back here, and the only other thing going on in here, in this gear, there's a keyway. And it's 90 degrees to that set screw. And remember, you got this set screw here, which locks it, and you got this set screw here, which is the plunger for the detent. So now, what we would want to happen is the spindle's going to slide out, this is going to stay inside the casting, and then yeah, I think you can see it in there. This is the key that attaches the gear to the spindle, and in this front dust cover there is a slot, and I can't I'll show it off, off of the assembly. There's a slot in this rear dust cover, front smaller dust cover. There's a slot in that dust cover that has to align to that keyway. So as you're pushing the spindle forward, you have to also time that keyway to that dust cover. So what's going to happen is we're going to walk this out, and I'm just going to rotate the dust cover. I'm going to try and get, so watch right here, as the spindle's being pushed through, that keyway has to come through this dust cover in that slot. So now what happens is the spindle comes through, and all these pieces are now free. And that's probably what will happen inside. And then this dust cover would obviously be stationary inside, and then the spindle is going to come through. Okay, so again, that slot there for both assembly and disassembly has to line up, with that key. And this here is the detent system for, well, I gotta loosen that set screw. It's down, locked in. So that plunger links into these, and then there's multiples. So now what I thought I would do is I would show how this goes back together. Like I said, these inner dust covers should be in the casting first. And then what you have to do is you have to get all the pieces in here, and there's just enough room to do this. That's that little tang system I was talking about. So what do I need now? I need a dust cover for the back. That would again be in the casting. Actually, before the dust cover, I need this collar. Then the rear dust cover. So at this point now, the key thing is to get this key through this dust cover and into the back gear. And I think what I will do when I actually do this assembly inside the casting, I'm going to mark this gear where the keyway is. So now you'd be pushing everything, all this assembly. And now what I have to do is I have to get the keyway lined up in the gear. Which again is a lot of things that have to come together at the same time. So I think the key's 90 degrees here to the plunger. No, 180 to that plunger. Where in the heck? No. Yeah. So the key is 90 degrees to that plunger. Okay. So now we're in there. I'm going to get this bushing back in. And now I think where I would be, working on not necessarily tightening anything up at this point, but now I would get the back bearing on. Get that into the race. So now we've got it supported, and then this set screw positions this gear. There should be a dimple in the spindle. This one's actually got a fair size hole in it. So you get that locked up, pulley up against that, gear up against that. And this guy likes to be in one position on this, on this particular machine, so that the gear is right tight up against the pulley. And we got this collar. That collar traps the pulley. So now that's all where it should be. The next thing that goes on is this bearing spacer. And there's a key for the spindle gear. I think I might have mixed up the two keys. There's a shorter one, I believe. So that key would be in there, which then locks the spindle gear. Then the collar goes on. And then in the manual, there's a procedure for snug plus 1 tooth. So as you rotate this 1/32 of a revolution, it's only 1 tooth. That's the preload, and you're supposed to do that after it's warmed up. So now the spindle's back together, and then dust covers. Oh, sorry. Dust cover before gear. Dust cover goes on. Ensuring you got alignment on that to the hole for the Gits oiler. Gear would go on, collar would go on. And then the back gear, and again, very similar, right? This gear has to be off. You bring the shaft in from the backside. You got your collar, gear, collar, front eccentric. And then the adjustment on the eccentrics collars is to center the whole assembly. So this collar and this collar here allow you to get that in there and in the right place. And by the way, if the plunger's linked between the back gear and the pulley, everything locks up and nothing will move. You don't want to run it that way. So hopefully that was good information for folks out there. That's the front dust cover going on there. I'll film probably when I put this thing back together into the casting. I'm not sure I'm going to try and spend time showing in through the holes in the casting how things go together. This is kind of my attempt to for my own self and others, is to understand that assembly and how it works.